In this video, we'll talk about the quadratic formula with imaginary solutions. What does an imaginary solution represent? The discriminant is a negative number. Therefore, the parabola does not intersect the x-axis. So recall what the discriminant reveals. So first of all, what is the discriminant? When we have the quadratic formula, x equals minus b plus or minus the square root of b squared minus 4ac, all divided by 2a, the terms under the radical are the discriminant. So we will just be looking at b squared minus 4ac and determining if that is a negative number, a positive number, or is equal to 0. So here is the discriminant written again, b squared minus 4ac. If that discriminant is a positive number, that will generate two real solutions, in other words, two x-intercepts. If the discriminant is equal to 0, we will have one real solution, and if we have a negative number under the radical, that results in two complex but not real solutions. And again, here is a graphical representation of these three situations. When the discriminant is greater than 0, that means a positive number under the radical. We have two x-intercepts. When the discriminant equals 0, it is one unique x-intercept. When we have a discriminant less than 0, that means a negative number, the parabola is not going to touch the x-axis. And it is also possible to have a parabola that's facing the other direction and not touching that x-axis. So remember, that all depends on what the lead coefficient of your quadratic equation is. So let's practice with a few problems. In example 1, we have 3x squared plus 6x plus 5 equals 0. So we have our terms written from the highest to lowest power and equal to 0. So we're going to generate the values for a, b, and c, and then substitute those into the quadratic formula. A is our lead coefficient, positive 3, B is positive 6, and C is positive 5. So using our quadratic formula, x equals minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. So our x value now is going to be equal to negative times b, which is 6, plus or minus the square root of b squared, that would be the quantity of 6 squared, minus 4 times a, that's 3, and c is 5. All divided by 2 times a, that's 2 times 3. So now our x value is negative times 6, or negative 6, plus or minus the quantity of 6 squared is 36, and our factors are negative 4 times 3 times 5. Negative times positive, that will be subtraction. 4 times 5 is 20, times 3 is 60. Now, of course, you could have done 4 times 3 is 12 times 5. We still have 60. Our denominator then, 2 times 3, would be 6. Simplifying what is under the radical now, 36 minus 60 will give us negative 24. So we want to simplify. Notice we have a negative number now under that radical. So we know that negative 24 under the square root would simplify as square root of minus 1 times square root of 24. Square root of negative 1 is going to clear the radical I. But 24, we'll have to work with our factor ladder to see if there's any perfect square factors involved. Since it's an even number, I'll divide by 2 to get 12. Dividing by 2, I get 6. Dividing by 2, I have 3. And dividing by 3, we have 1. So here is a pair of identical factors giving us 4, and 2 and 3 are the other factors, making 6. So we have square root 4 times square root 6. 4 is a perfect square, that is 2. So 2 square roots of 6 is how we're going to simplify square root of 24. When we simplify the problem now, x is going to equal negative 6 plus or minus 2i square roots of 6, all divided by 6. So I'm going to separate each of these terms, so that will allow us to put this in the proper a plus bi form. And it also has a bonus in that it allows us to reduce any fractions. So looking for reducing, I can see that 6 divided by 6 makes 1, and there is a negative there with it. And 2 divided by 6 could reduce to 1/3. So let's see what our two solutions would look like. X now equals negative 1 minus I square roots of 6 over 3. And notice only the imaginary portion is divided by 3, not this first term. That reduced to negative 1, so there's no fraction for that piece. The other solution would be x equals negative 1 plus I square roots of 6 divided by 3. Now don't reduce this 6 and 3 because 6 is under the radical and therefore it cannot reduce with a term that is outside of a radical. So you can see that we have two complex solutions here, and it means there's no x-intercept. In our second example, we have 9x squared plus x plus 2 equals 0. That's in the proper order and equal to 0. So value of A is 9. B, that plus x means plus 1x, so B is worth 1. And C must be positive 2. Using the quadratic formula, x equals minus b plus or minus square root of b squared minus 4ac, all divided by 2a. We'll make our substitutions. Negative times b means negative 1 plus or minus the square root of 1 squared minus 4 times 9 times 2. Our denominator, 2 times a, means 2 times 9. When we simplify, negative times 1 is negative 1, plus or minus. Under our radical, we have the quantity of 1 squared, that's 1, and our three factors, negative 4 times 9 times 2. Negative times positive times negative. So we will be subtracting. 4 times 9 is 36, and 36 times 2 is 72. Our divisor now, 2 times 9 would be 18. Let's simplify under the radical. 1 minus 72. Well, I can tell that's going to be a negative number because 1 minus something much larger will be a negative, and that would be negative 71. Again, with a negative under the radical, this factor of negative 71 would have factors of negative 1 and positive 71. 71 is a prime number, so we won't be able to break that down with a factor ladder. So we would simplify square root of negative 1 as our imaginary number I and keep square root 71. So x is going to equal negative 1 plus or minus I square root of 71. And our denominator of 18 I'm going to use separately, and each term is divided by 18. So if you'd like to separate those solutions, you would have x equals negative 1 minus I square roots of 71, each divided by 18. And then we have addition. X equals minus 1 plus I square roots of 71, each divided by 18. So again, we have two complex solutions. That means there is no x-intercept. In example 3, we have negative x squared minus 2x minus 7 equals 0. So we have the proper order and equal to 0. So it's standard form. Value of a, that negative, remember, represents negative 1. Value for b is negative 2. And c is negative 7. So everything is a negative this time. With our quadratic formula, x equals minus b plus or minus the square root of b squared minus 4ac, and we'll divide by 2a. Making the substitutions, x is equal to negative times the b value. B, remember, is negative, so that negative needs to be included in the quantity. Plus or minus square root of b squared. Again, we need to have that negative included in the quantity. Minus 4 times a times c. So I substitute negative 1 for a, negative 1 for 7, and negative 7 for c. Division of 2a means 2 times minus 1. Let's simplify now. Negative times negative 2 makes positive 2. Plus or minus. Quantity of negative 2 means negative 2 times negative 2. That would be positive 4. And our three factors, negative 4 times negative 1 times negative 7. So a negative times a negative times a negative means we will be subtracting. 4 times 1 is 4. 4 times 7 is 28. So we're subtracting 28 from 4. Denominator, 2 times minus 1 is negative 2. Let's simplify under the radical now. 4 minus 28 is negative 24. Since we have that negative, we know that it's going to break into the factors of negative 1 and positive 24. And we have used 24 earlier when we worked with our perfect squares. Remember, we came up with square root of 4 and square root of 6. So that made 2 square roots of 6. So when we simplify, x equals 2 plus or minus 2i square roots of 6, all divided by negative 2. So remember here in this step, square root of negative 1 was our imaginary I. So I times 2 times square root of 6 in the proper order would be 2i square roots of 6. So to break this into its two separate solutions, I would have x equals 2 minus 2i square root of 6, and our denominator is negative 2. I'm going to separate a from bi. That's our complex format. And the other solution would be x value equals 2 plus 2i square roots of 6. Again, each term is divided by negative 2. And this would allow us to do some simplifying. So we would end up with 2 divided by negative 2 is negative 1. The negative 2 divided by negative 2 makes positive I square root of 6. This is where we have to be careful. In our other solution, we have 2 divided by negative 2. That would still be negative 1. And reducing positive 2 with negative 2 makes negative I square root of 6. So it looks like we started out writing that first term as subtraction, but because it was divided by a negative, it changed to plus. And the same is true for the other solution. We started with plus, but since it was divided by a negative number, this problem became subtraction. Now what we haven't done is made a sketch of each of these. So let's go back to the first example, and we'll make a quick sketch of this parabola. Remember, there's no x-intercept because we had a negative number under the radical. But we can look at what direction the parabola opens from the lead coefficient. It is a positive, so it's going to be opening upwards, and it's not going to have any x-intercept. It would be quick to find the y-intercept actually for this problem, because if we let x equal 0, we will know the y-intercept. So the first and second terms are eliminated. We're left with 5. So that tells us 0, 5 is the y-intercept. So if there's 0, 5, and we know that this parabola does not cross the x-axis, then I can go ahead and sketch a graph of this parabola, not touching the x-axis. In example 2, So we're going to, again, plot the y-intercept, and then based on the lead coefficient, we'll determine if the parabola opens up or down. So we have a lead coefficient that's a positive 9, so it should be opening upwards. To plot the y-intercept, we let x value equal 0. So 9 times 0 squared plus 0 plus 2. The first two terms are eliminated, leaving us 2. So 0, 2 is the y-intercept. There's our y-intercept. We know the parabola opens upwards, so it might end up looking something like this. And in our last example, plotting the y-intercept, again letting x equal 0. So negative times 0 squared minus 2 times 0 minus 7. So the first two terms are eliminated, and we have negative 7. So 0, negative 7 is our y-intercept. Checking the lead coefficient. See this negative in front of x? That means our parabola is opening down. So it would look something like that. Now, in a later lesson, we are going to find out more information about these parabolas and not just sketch them, but actually plot several ordered pairs and determine vertex points, x-intercepts, y-intercepts, and have a complete graph of the quadratic equation. But for our purposes here, we're just making a sketch. But it is obvious to notice this parabola does not cross the x-axis.